Welcome to my educational series where you can improve your English proficiency and prepare for exams like TOEFL and IELTS. In this episode, we'll focus on an academic topic. You will hear a talk followed by several questions. I recommend that you take some notes while listening because it will help you at the end of the conversation to answer all of the questions in the quiz correctly. So let's listen to it.
Ever catch yourself just completely baffled by your own brain? It's this thing we all have, controls literally everything we do, but trying to actually understand it, it can feel a little overwhelming.
It really is remarkable, isn't it? I mean, we're talking about the most complex structure in the known universe right here inside our skulls.
Seriously. But hey, that curiosity that brought you here today? That's awesome because we've been doing some serious digging into this fascinating source, osteopars, and our goal today is to make the brain a bit less of a mystery.
Yeah, we want to give you a solid grasp of what's happening up there without getting bogged down in overly technical jargon.
Think of it like a guided tour through the most important parts of your brain, from the basics to the stuff that makes you, uniquely you.
Exactly. We're talking about the functions that keep you alive, the processes that drive your thoughts and feelings, everything.
Okay, so let's start with the big picture, the main stage, so to speak, and that's the cerebrum, right? This is the largest part of the brain, and from what I've read in Shu, it's divided into two distinct halves, or hemispheres.
You got it. And it's almost like having two brains working together, which is kind of mind-blowing when you think about it. Each hemisphere has its own specialties. So the left hemisphere, typically it controls the movements of the right side of your body, and it's also heavily involved in things like language, math, and logic.
Okay, so that's like the analytical side.
You could say that, yeah. And then you have the right hemisphere, which controls the left side of your body, and it tends to be more associated with creativity, music, art, and those sorts of things.
So that's the artistic side, but they're not totally separate, are they?
No, not at all. They're constantly communicating and working together. It's more like they have different strengths, but they collaborate to give us a complete picture of the world.
Gotcha. That makes sense. And all of this complex activity, this processing and whatnot, it's happening in the outer layer of the cerebrum, which is called the cortex, according to Ashimria.
Exactly. And the cortex is pretty amazing. It's this highly folded layer, and all those folds are there for a reason. They increase the surface area, which means you can pack in more neurons, those brain cells that do all the heavy lifting.
More neurons, more processing power.
Exactly. And within the cortex, you've got different zones that specialize in certain tasks. So there are motor areas that control movement, sensory areas that process information from your senses, and then there are these association areas.
Association areas? Those sound intriguing. What do they do?
Well, think about it like this. Your senses are constantly bombarding your brain with raw data. Sights, sounds, smells, all of that. And your motor areas are responsible for executing movements. But the association areas, they're the ones that take all of that information and actually make sense of it.
So they're like the integrators, the meaning makers.
Precisely. They're the ones that help you recognize objects, understand language, make decisions, and all those higher level cognitive functions.
Okay, that's starting to paint a clearer picture. Now, if the cerebrum is like the brain's main office, Sanjolso says the prefrontal cortex is like the executive suite. It's the most complex part of the cerebrum, and it seems like this is where things get really personal. Like, this is what makes you you.
That's a great way to put it. The prefrontal cortex is really fascinating. It's where our most advanced cognitive abilities reside. Things like personality, intellect, reasoning, planning, creativity, even our conscience, all those things that we consider to be uniquely human.
It's almost like the prefrontal cortex is the conductor of the orchestra, right?
Yeah.
Orchestrating all these different functions to create a cohesive experience of the world and of ourselves.
A very apt analogy. Now let's shift gears a bit and talk about some specific areas within the brain that are involved in language. So Vilmius specifically mentions Broca's area. Have you heard of that one?
I have. It's something to do with speech, right?
Right. Broca's area is crucial for the production of speech. It's typically located in the left hemisphere, and it's responsible for planning the movements of your mouth, tongue, and vocal cords that allow you to form words and speak fluently.
So it's like the speech architect figuring out the blueprints for forming words.
Exactly. And we know about this area thanks to a French physician named Paul Broca, who studied patients with speech difficulties back in the 19th century. He noticed that damage to a specific part of the brain which we now call Broca's area, led to problems with speech production.
Fascinating stuff. And then there's Wernicke's area, right? What's that one all about?
Wernicke's area, also usually found in the left hemisphere, is all about understanding language. So while Broca's area helps you speak, Wernicke's area helps you comprehend what others are saying and what you're reading.
So they're like partners in crime working together to make communication possible.
Exactly. And what's really cool is that they're connected by a bundle of nerve fibers, so there's constant communication between these two areas.
Makes sense. Okay, let's move on to movement. P.S. Nastas starts by talking about the premotor cortex. What's its role in all of this?
The premotor cortex is like the planning stage for movement. It helps you sequence and coordinate complex actions, especially learn skills like playing an instrument or riding a bike.
So it's like the choreographer of our movements.
I like that analogy. It's figuring out the steps involved in a particular action.
And then we have the primary motor cortex, right? What does it do?
The primary motor cortex is where the rubber meets the road, so to speak. It's the part of the brain that sends the actual commands to your muscles, telling them to contract and produce movement.
So it's like the command center sending out the orders to all the different muscle groups.
Exactly. It receives input from other parts of the brain, including the premotor cortex, and then it executes the movements.
And we can't forget about the cerebellum, right? That little cauliflower-shaped structure at the back of the brain. What does it do?
The cerebellum is all about coordination, balance, and precision. It's constantly monitoring your body's position and movements, making tiny adjustments to keep you steady and to ensure your movements are smooth and accurate.
So it's like our internal gyroscope, keeping us upright and balanced.
Exactly. And it plays a huge role in things like walking, playing sports, dancing, any activity that requires precise control of your movements.
Okay, now let's dive into the senses, starting with touch. UBR mentions the primary sensory cortex. What happens there?
The primary sensory cortex is the first stop for sensory information coming from your skin. It processes things like touch, pressure, temperature, pain, all those sensations that let you experience the physical world.
So it's like the brain's receptionist for all things tactile. And Uyer points out that areas with more sensory receptors, like our fingertips and lips, have a larger representation in the primary sensory cortex. Is that right?
That's absolutely right. It's why those areas are so much more sensitive than, say, the skin on your back. They have a higher density of receptors sending information to the brain.
That makes sense. And then we have the sensory association cortex. What's its job?
The sensory association cortex takes the raw data from the primary sensory cortex and puts it into context. It analyzes the information, compares it to past experiences, and helps you identify objects and understand what you're feeling.
So it's like going from, hey, something's touching my hand, to, oh, that's my coffee mug.
Exactly. It's where the raw sensation becomes a meaningful perception.
Cool. Let's talk about vision now. We start with the primary visual cortex. What's going on there?
The primary visual cortex is at the back of the brain, and it's the first stop for information coming from your eyes. It processes basic visual elements like lines, shapes, colors, and movement.
So it's kind of like the brain's photo editor, taking in all the raw visual data and starting to organize it.
I like that analogy.
Yeah.
And then you have the visual association cortex.
Visual association cortex. What does it do?
Well, the visual association cortex takes all that basic visual information and interprets it. It compares it to your memories, helps you recognize objects and faces, and allows you to understand the spatial relationships between objects.
So it's like the visual association cortex is saying, okay, those lines and colors and shapes, that's a tree and it's about 10 feet away from me.
Precisely. It's where the raw visual data becomes a meaningful scene that you can perceive and interact with.
Makes sense. Okay, last but not least, let's talk about hearing. We've got the primary auditory cortex. What does it do?
The primary auditory cortex, located in the temporal lobes, is the first processing center for sound. It analyzes the basic qualities of sound, like loudness, pitch, and rhythm.
So it's like the sound engineer in our brains breaking down the raw sound waves.
Exactly. And then we have the auditory association area.
The auditory association area, what's its role?
Well, the auditory association area takes those basic sound elements and gives them meaning. It's where you recognize voices, identify music, and understand spoken language.
So it's like the DJ, taking all those different sounds and mixing them into a coherent track that we can understand and enjoy.
A perfect analogy.
It's amazing to think about all of these specialized areas working together seamlessly, allowing us to experience the world in such rich detail. Going through a K like this has really highlighted the incredible complexity and interconnectedness of the brain.
It really is remarkable, and hopefully Now you have a bit more insight into the incredible organ that's driving everything you do.
Absolutely. As you go about your day, maybe think about how different parts of your brain are involved in your activities. Whether you're reading a book, playing a sport, or simply having a conversation, it's all thanks to the amazing orchestra of activity happening inside your head.
And remember, we've only just scratched the surface here. There's so much more to learn about the brain, and new discoveries are being made all the time.
Yeah, this deep dive has been fascinating, but it's definitely just the beginning of the journey. So keep that curiosity alive, keep exploring, and keep learning about the amazing universe that exists within your own skull.
Thank you for joining me today. I hope you have learned something new and useful, and see you in the next episode. Bye.